ESPRIT's digital twin is a game changer to feed optimized programs to your machine. In this tutorial, we will show you how to build a lathe chuck body and jaw models to take your programming to the next level. Identify program changes upstream of the machine. So let's get started. So the first thing that we want to check out is whether or not the solid model is positioned and oriented correctly. So this is Kitagawa chuck. This is their BR08 that you can download from their website. So if you want to follow along, you can go to the Kitagawa website and grab this one. This one is the BR08_OC. So we first want to orient this. So we notice that the face of the chuck is oriented along X. We want that to be along Z. And while I'm doing this, I'm just going to set my 0 point to where this would mount. So these are the mounting screws. So I'm going to pick this back face here. And when I do that, I'm going to make sure just to highlight that face. And, you know, when you start ESPRIT, you can do that, but you can also switch your filter so that you can basically click away here on the, not on one of these icons, but in the square, but where it says bodies, and then you can pick face. And that way only faces will be picked. So you don't have to do as much highlight mode stuff. So what you could do is pick this mounting face, and what we're going to do here is come to the home ribbon and come over here to the align commands, and I'm going to pick align Z. And you'll notice that the align Z command will align that face so that it's normal to the Z axis. But we want the opposite result. So what we want to do is activate this command by while we're holding the shift key. So we're going to go ahead and hold shift and pick align Z. And we see that the Z axis is now normal, but going in toward the face that we selected. And that looks pretty good. So the other thing here, so you can basically use that command either way, but we want the Z-axis coming off of the machine basically into the lathe chuck. So looking at the jaws, in my head I like to have one of the jaws aligned along the X. So we can see here that looking at this, I'm just going to assume that this is aligned along the Y. So I want to rotate this about the Z-axis here. I want to basically do this and rotate this, so that it's minus 90 degrees, even with the X-axis. So I'm going to just hit Control-A on my keyboard, or you can hit right-click, select all, and then I'm going to right-click again and say copy, and I'm going to say rotate. And we're going to say move minus 90. And using the origin is fine. So once you hit enter, the solid assembly for the chuck will rotate, and you should have this jaw here even with the X-axis. Okay? So now let's take a look at the solid itself. Now that we've oriented and positioned everything the way that we want, I can see here that if I need to turn my selection filter off, so I'm just going to turn on the bodies. So now I can pick faces or bodies, and I see that we've got some individual solids here, which is good. We want to have these jaws separate. I've seen some where they're all in one, so you got to do some CAD work. So we see that the screws, all this stuff for the jaw assembly is separate, which is good. And then the chuck body looks like everything is in one, which this is a BR08, and per their website, you've got that center bore which allows bar stock to slide through. So I could see that they have this component that bolts onto the back. You know, what we're gonna want to do a little bit of CAD work with this. So, okay, what do we want to do next? So what I'm going to do here is go to F4. And F4 gives me the view that is the lathe view. And I'm going to come here and create a new layer called jaws, or jaw, whatever. So what I want to do now is basically turn off. Now I'm going to go back to the F4 view here. And what I'm going to do is just kind of window in on these front jaws, and then I'm going to come to the properties and I'm going to turn this to the jaw layer. And when I do that, we're going to turn this off, and we now have these three base units for the jaw assembly here, in addition to the chuck body that's visible. These I don't really need anymore, so I'm just going to delete them. Get rid of those two, and actually let's do this, and we don't need any of this stuff either, because basically we're going to make a jaw assembly that will automatically be loaded onto the chuck jaw. Okay, one other consideration is going to be the positioning of the jaw itself. So we want this jaw to be in the open position. So when I look in the manual for this chuck body, you know, they say that this T-slot nut here, it should not protrude in operation beyond, you know, this face here. So what we're going to do is just highlight this chuck body and hit Control W on the keyboard. And remember, this is already aligned along X. I could just right-click, copy, translate, and about X, I'm just going to say, let's say 0.6. And that moves this this jaw assembly so that it's slightly beyond, which, you know, when you have material in here in the ESPRIT simulation, the jaws are just going to automatically close up to the diameter of your workpiece. So once we've positioned that, then we're good to go. I always like to put things a little bit further than the normal range. Now, ESPRIT will, if you have a workpiece that can't be positioned in your existing jaw because there's not enough stroke or something, you know, it will let you know. So it's up to you on how accurate you want to place that. So, but let's go ahead and continue. So let's do a couple things first. So I'm going to turn my jaw layer off again, and we'll go back to activate. So double click on default, make sure default is active. And what I want to do here is I want to get rid of this center portion so that if we had bar stock sliding through, you know, we don't have any chance for a collision in the ESPRIT simulation. So what I'm going to do here is pick this. I'm going to go down here to select filter, and I'm just going to basically click on the box and enable everything. So I'm going to pick this edge, and I'm going to right click and say copy, and we're going to say smash, and make sure your wireframe is checked. And then what I want to do with this arc is I'm going to come up here to geometry, keep, and I'm going to hold my shift key down. So you want to hold shift down, and that is going to basically unbound your arc into a full circle. Okay, so once I've done that, you could go ahead and hit the escape key, get out of that command, and then pick your circle. If you're still active in one of these modes, it shouldn't affect geometry, but if you're not able to pick your circle, just make sure that you don't have any geometry filters selected. So what we're going to do here now is pick this solid. So we want to see right here, it said on mine, it says solid model number 11. Okay, so comma 11. So we want to remember that. So I'm going to pick this circle, and I'm going to come to modeling and go to extrude. And we're going to go the opposite direction. We're going to go inward, and I'm just going to make this a big old number like 5. And we can see it goes through the whole thing. And I'm going to say the active solid is body 11. And here I'm going to say cut set to yes. I'm going to say OK. And if I look down the center now, there's no obstructions for the bar. So that's going in and out, no problem. Shouldn't have any collisions when I'm executing machining on the machine, doing a bar pull or something like that. So, okay. What else do we want to do? Me personally, I'm going to do some coloring right here. So if you want to skip this and you don't care, you can skip ahead. But at this point, I'm going to change a few faces. So I'm going to come down here, and just to make the highlight mode a little bit easier, I'm going to pick those two, go to copy, come to attribute, and pick blue. I'm going to pick the K, right click, go to copy, go to attribute, pick white. And then I want to pick all these little faces that define the Kitagawa logo for the word. And I'm going to grab these here at the top for the BR8. Make sure that you're holding control the entire time that you do this so that you're adding to the group. You can add any face or remove any face from a group by holding control. Right click, copy, I'm going to say black. And just to make it look a little bit nicer. So at this point now we want to define our jaws. So we have this base unit, and the reason that I have this is I want to use that to define my jaw axis. So these are going to move, and I need to define a position where the jaw is located and where it will be loaded. So I want it to appear on top of this base unit, okay? And I want the whole jaw assembly to appear in this slot so that it's gonna, move along the x-axis, because if you recall, we made this even with the x-axis, and fit on my bar diameter. So right here, what I'm gonna do is maybe pick the center of the chamfer bore here as my location point. So this is already oriented along x in the direction of the axis as it slides along the x. So I'm going to come here to the home, and I'm going to go to translate work plane. I'm going to activate the command, and then I'm going to rotate a little bit sideways here so we can see. Make sure that you pick this outer one, not the inner one, the outer one. I guess it doesn't really matter, but you could pick whatever you want. You could pick this point or the center. You could do whatever you want, but I'm going to pick this and come here to make a new work plane and call this JA_1. Okay, so this is a jaw adapter number 1, basically, JA_1. Really quick too, I want to get this dimension from the center here to my z-axis. It'll be clear a little bit later why. I'm going to just go ahead and pick this dimension here, and now I have this segment that gives me this length, which is 2.109. So now what I want to do is take this jaw axis and duplicate that at 120 and 240 degrees. So to do this, we can go back to the home, come over here to the rotate command. So we want to rotate our work plane, and down here at the left it says select a line of rotation, and we're going to pick our z-axis, and then down here it says what's the angle of rotation. We're going to put in 120 for 120 and hit enter. And now we see that that work plane is located at the next jaw, and you can see that the u-axis, or the local x-axis, is parallel to that slot. So we're going to come here and just do a JA_2 And then we're going to do this again. And here you could just hit enter 3 times. Line of rotation LZ 120, and it moves it to this next position. And I'm going to say add another one, _3, and now we have JA1, JA2, and JA3 to define all 3 jaw adapters. Now, what I want to do is define, in case maybe I want to load like an intermediate fixture on this chuck. So I'm going to do that. Let's go ahead and pick that. So we're going to come here to, let's go back to the XYZ first. So I'm going to do that, and then I'm going to come to the center of the face. So I'm going to come back to translate, activate, and then kind of coming to the side here. We want to pick that center point. You can see this is the one that defines the face. So as I move my mouse, make sure that you pick that center point there. I guess you could always move this stuff in the ESPRIT interface when you're setting up your simulation anyway. So it's not a huge deal if you pick the wrong one. But let's make this an FA_1, which is a fixture adapter _1. And we're going to do this translate one more time. And I'm going to do 0, 0, and say like 5 inches. And I'm going to basically define this as a workpiece adapter. So I'm going to do another work plane. This is WA_1. So a workpiece adapter is going to allow me to put my part, in the simulation, and it will be positioned at that point. So why so far in front of the face of the chuck? Well, you'll see basically typically most people set their part at like a G54 at the face, and then the part extends backward. So what would happen if you placed it here is your whole part would be here, then I'd have to move it forward and then maybe move it back. So this gives me a little bit of room here that if the part is shorter than 5 inches, I could probably do a alignment mating on that, no problem, without having to move it once. So here we go, we're going to make the jaws. So before we do anything at this point, I'm going to take this and I'm going to put this on the jaw. So I'm going to come here and we're going to highlight this solid model here, okay? So we're going to make sure that that solid is highlighted, and I'm going to come here and place this on the jaw layer, all right? So once we do that, it should, if you have it visible, it won't disappear. I had mine turned off. So we basically have created the GDML for the chuck body. And we're going to go ahead and save this out. So if this is your first one, you might want to save the ESPRIT file. So you might want to come here and go File, Save As, and I'm going to come here to my fixtures, Kitagawa, and I'm just going to say File, save this as BR08_OC. And that way I save my work, and if I made a mistake, I don't have to go and do all those things again. But now what I'm going to do is highlight the chuck body. The geometry doesn't matter. It's not going to be saved as part of the GDML, but this is my fixture body for the chuck. So I don't want to have any jaw stuff highlighted with it. So when you highlight something, it's going and save a GDML, it's only going to save what you have highlighted. So we want to take this particular component and come here and say File and say Save As, and we're going to say Fixture File. And here I've already made it, so we'll just resave this. And we've saved the chuck body. Now, just really quick here, I'm not super familiar with these chucks, so I'm not sure if this bore should include this or this should be removed as well. So, depending on what the real component looks like, it's likely that this interior area here with these 3 screws, that might need to be, might need to model that away also, I don't know. But anyway, we can pick this here and look at the solids tab, and this is going to tell us that this is a 2.6 inch diameter bar, so like a 2.5 diameter bar can fit through here. So maybe that's correct. Okay, so now we want to do the jaws. So we want to come back to JA1, and this is going to be where we want the jaw to appear. So naturally, this is going to be the point that we want to define the jaw at x, y, z, 0. Okay, so we've saved out the file, we've saved out the GDML. What I'm going to do here is basically delete this. I don't need that anymore. I don't need this either. I'm just going to delete that. I'm going to come to jaw, turn that back on. Okay, and this 0 point at JA is where I want my XYZ 0. So the easiest way to do this is to just do a move origin to this point. Okay, so we're at JA1, so we can see where this is at. So I'm going to come here to a clear view because we're picking inside all this, and going to clear makes it more visible. I can more easily see my highlight mode. So what we want to do now is move our origin point to this point, and that will snap our jaw to that position. So now what I'm going to do here is just get rid of all this. I'm just going to highlight each one and hit the delete key, and we're basically left with our default G17, G18, G19 planes, or ZXY, YZX. And looking at this, this is positioned, we didn't, by moving the origin point, it just basically snapped the 0 point to where we want. All right, so we have this segment here, and the reason I wanted this segment is because the end of this segment defines where the turning center axis of the machine is. So at this point, I have an ESPRIT file that I'm going to come here and go File, Save As, and I'm going to call this BR08OC jaw, which I saved already. Just going to save over that. So I'm saving the jaw file separately. So now, if I wanted to come in here and make, you want to cut down this jaw, you could come in here and say, oh, I'm gonna have a 1 inch workpiece. So we can, pick, whatever we want to do, radius of 0.5 or radius of 1 for a 2 inch diameter workpiece, and then you can extrude and cut away so that your jaw, so we can save out multiple jaws. I don't have to wonder where that center point is anymore. But basically, we've positioned our jaw, and there's really nothing else that we need to do at this point. We're just going to come over here and say File, Save As, come over here to Jaw File, and we want to make a BR08OC jaw, and I already did this. I'll just File, Save over that. And now we have our chuck body and our jaw, and we're ready to use them in a ESPRIT simulation. For a part that you want to do, and we'll look at the part setup here. I just whipped this together. Under the stock, we have an outside diameter of 1 inch, let's say, on something that we're going to machine. We would come to the machine setup, and let's just load in a Haas machine, and we see the machine here. So we'll zoom in, and I'll come to, basically we want to load a fixture first. So we want to first bring in that chuck body that we created. So we're going to go to the Kitagawa here and BR08. There we go. And we see that is brought in. And now we're going to come to jaws. So this is highlighted. We're going to come to jaws, and we're going to grab the basic jaw that we made, which was the one that was supplied with the solid from the website. So we can see here that that functions no problem. So we're going to come and set, maybe under machine setup, you can on the chuck body itself, since we created that FA position, FA fixture adapter _1, we can have the workpiece added to this as well. So let's go ahead and do that. And depending on what you want to do, you can pick the let's say the face of the chuck and the face of the back side of the stock. Holding the control key, you want to pick the two so that they're both highlighted, and then do the alignment mating, and it will snap the part back up against the chuck body. So you can see that is there. Let's bring this so we can see the part. Now, what I was talking about before with the jaw stuff is you can do that cut extrude. So I went ahead and did that with several different circle diameters so that we can see what that looks like. So here we want to come to the machine setup and double click on the jaws, and we'll change the jaw. So this is a 1-inch diameter, I believe. I already forgot, but we're going to pick the 1-inch diameter, and I'm going to say OK. And you'll see that the chuck jaw solids have changed. So now what I'm going to do is say OK, and on the workpiece side, I'm going to kick this back out. So this is what I meant, is originally you would have to do this. So now if I had just done this the first time, my workpiece would already be out here. I'm going to pick one of these faces here, and then holding the control key, we're gonna zoom out and rotate, and I'm going to zoom in and pick that back face. So I have, with the control key, I have this face and this face selected, and then I can come here to snap that to that back face, and now you can see, beautiful. The 1-inch diameter bar stock fits right on the 1-inch turned jaws. So if you have some soft jaws, or I just used the jaw solid that was provided with the Kitagawa, the serrated jaw here. But if you were using a different jaw or whatever, you just want to make sure that that's positioned correctly, and now you could use that in the simulation. So as an example here, I brought in a part, and we're just going to bring this in and start the simulation, and we can see that the part, everything is working fine. We're going to scroll down here to the OD milling, and when I start the simulation, we see our tool come in, and you can see here that with the clamping unit and the holder, the live milling holder, that we are very close to that chuck jaw. So we want to make sure that we don't have any issues at the machine, because once this program is created and sent to the machine and we discover that issue at the machine, we're going to have editing and everything is going to be delayed. The machine will be sitting and waiting for the program. And additionally, now we can see all these links are green, which means that they're collision free. But even though that this is checking that holder, we might have another issue. So here we see this tool is coming down to mill this OD area, but you can see the positioning of our chuck jaw is causing a collision between this clamping unit here, this live holder, and our chuck jaw. So even though we're using this tool here, I know that I need a longer tool so that this is going to be not in the way, or maybe I need to change the configuration of my turret to move this holder somewhere else so that this one is not in this position when I'm doing this milling. So again, having this information, this accurate digital twin upstream of the machine, allows me to send a more confident, more proven program to the machine tool. So hopefully the new digital twin capabilities in ESPRIT will allow you guys to make more parts.